On with the show. Johnny Gilbert, before every episode of Jeopardy, always says to the audience, "Quiet, please." Yeah, he's the announcer for the game show Jeopardy, and has been for the last 31 years. Okay, everyone can see the screen. Everyone can see my mouse. That's good. Welcome, everyone. Let me set the timer, and we will begin. This is a presentation of an app that I built over the course of the last year, and how it could be applicable for the classroom, especially for teachers of English as a second language. I named the app after a former teacher of mine, who we will see in a moment. It was named McCawley, and it is a web app for drawing colorful syntactic trees. The outline of this presentation is as follows. We talk about syntactic trees. I will talk a little bit about syntax. We will show off the application McCawley, as I've named it, and we will review some potential uses in the classroom for teachers and students. A very brief overview / reminder of what syntax is. Our good friends at the American Heritage Dictionary, 4th edition, tell us that the word syntax itself, at least when it applies to natural language, is the study of the rules whereby words or other elements of sentence structure are combined to form grammatical sentences. To elaborate on this a little bit, everyone knows that words can be classified as parts of speech, the canonical noun, verb, adverb, adjective, and so on. Those parts of speech can assemble into structures given the rules of the syntax of English. For example, we can take a very short example, that of the shortest sentence in the King James Version of the Bible. The book of John, chapter 11, verse 35. Just 2 words. Jesus wept. Jesus is a noun, wept is a verb. English, it so happens, has a rule that says that a noun and a verb can combine to form a sentence. That rule is where's my mouse? Right over here. Noun plus verb equals sentence. And that's one of a number of rules that English has when it comes to parts of speech and them forming larger constituents, as they're called, larger pieces. So here's a noun and a determiner, basically a synonym of an article, a, an, or the, which combine to form a noun phrase. And that noun phrase could go into a slot like this. And you see how a structure like that would build to be able to make the sentences of a grammatical sentence in English. I built an application that does this and that demonstrates this. And I'm not the first to do that. For example, here is an application, a website that you can actually go to now, and which we'll go to in a moment, which actually does the same thing of the app that I built. But it's not exactly the most exciting. Okay. As I was saying, we have an application here that you can find online, nlp.viz.bpodgorski.com, the developer who built this. And you basically type in what you want to parse, and the parsing will appear here as an example like this. And it draws a tree, and you see the constituents, and you see that they're labeled. But I didn't see it as being terribly friendly, nor did it actually appear to me to be terribly dynamic. And I thought to myself, I could do better than that. And so I did, which we will see. The application, as I mentioned, is named after McCawley. The McCawley in question is this guy, Professor James David McCawley. He was professor of linguistics at the University of Chicago and regarded, at least among linguists, as one of the premier syntactic theorists of the 20th century. He passed away 17 years ago, back in 1999. He was just 61 years old. He died of a sudden heart attack out of the blue. And it's in his memory that I actually named the app for him. He was actually a teacher and friend of mine. The app for which I've named it, kind of like the NLP app that we had just seen, a natural language processing app, takes an English sentence as input and dynamically draws a syntactic tree following what's called constituent analysis along the lines of parts of speech that assemble into larger pieces that then assemble into larger pieces still, and that draws that as output, and also provides a number of related statistics, which we'll see in a moment. The software that is used to help to build this involves a number of programming libraries, that is, sets of software that are made publicly available that people can then use for different things. In this case, building a tree of syntactic pieces. Stanford University has kindly made available one such library that they call the Core NLP library. In fact, if you were to look up the Stanford Core NLP project, you can find the team of researchers at Stanford who work on this and who have made available the software that they use for this, not just in English, but actually in a number of assorted languages. That library makes use of another resource courtesy of friends at the University of Pennsylvania Department of Linguistics, the Penn Tree Bank part of speech tags. The parts of speech that are used for this application aren't just the canonical noun, verb, adverb, and adjective. It turns out that they've got a set of specialized speech tags, 38 of them, that are used in the course of this application. We'll see some of them in a moment. The programming language that's used for this is a fairly recent language called Clojure, but spelled with a J, as you see here, as well as an affiliated version that's useful for web applications called ClojureScript. It's a fairly new and recent language. It's only about 8 years old. But it has really caught on among software developers, and it's actually what I've used to build the app that you're about to see. It actually compiles to programming language JavaScript that is actually kind of like the lingua franca for developers and development on the web. Clojure and ClojureScript developed to JavaScript, which you can use for a website, and that's what I did. Enough talking, let's see this in action. And I'm happy to report that this is available online. I've rebranded it slightly with the clever name The Parse is Right. You can courtesy my 6-year-old son who cleverly came that up. But it is available online now. All you have to do is go online to www.theparseisright.com. You have a field here where you can actually type in a word, which I've actually already done. It appears at the very top here. And once you're ready, you can actually select a color scheme. I'm going to select rainbow colors, and then I select parse. And ta-da! So you've got a number of constituents that are here, an S for sentence, a CC for coordinating conjunction, NN for singular non-specific noun. You've got a determiner, an or the, basically a synonym for an article. The formal term in linguistics is a copula, but basically think of it as a linking verb. In this case, the is, all the world's a stage, and all the men and women merely players. RB for adverb, adverbial phrase, noun phrase, and so on. You can actually see the pieces and how they fit together. You have a number of statistics that are here. It might be a little hard to read, so I'll go through them. The number of nodes. This sentence happens to have 25 nodes. So here's a node. They basically coincide with these squares that are colored in with a part of speech. So there's a node, 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 there's a node. 25 in all in this example. The number of words basically coincides with what you have here breaking up by space. When you count them out, there are 13. The number of parsed words differ from the number of words. Here's an example. All the world's a stage. Worlds up here counts as a single word. But as far as the parsed words are concerned, they count as 2 words. World being a noun, and z representing is being a linking verb in a verb phrase. So that actually counts as 2 parsed words. Propositions. That basically coincides with idea-bearing units, and that basically refers to the number of, in certain psychological and neurological research, this actually proves to be a useful metric. It basically coincides with a number of entities that are carry idea-bearing units. They usually coincide with, I think it's a verb, an adjective, an adverb, and a prepositional phrase. We can actually see that when we actually take this. I can reset the screen, actually paste it back in, select highlight props for the propositions, and we will see the exact same tree drawn up, but the coloring will be slightly different. You will note that the number of propositions, which we had seen as number 3, are now highlighted here in orange, and everything else being grayed out. This allows you to very quickly assess where are those idea-bearing units? And this actually can matter, and I've given a presentation on this before, in certain research in certain areas regarding how many ideas you have within a given sentence. And that actually is correlated with other things, as other research has shown. You have the number of propositions per 10 words. So basically taking the number of words that you have up here, multiplying by 10, dividing by the number of propositions, rounding down, and you get a number here. The depth. So this is, as a tree, layered. And you actually is a count of the number of layers. So counting up here from 0, 1, 2, 3, 4. 4 levels deep. That's what the max depth refers to. And then you have a count of the most frequent nodes based on their speech type. So this sentence happens to have 3 determiners, 3 sentences, there's an S, there's an S, there's an S, 3 noun phrases, 3, I think that refers to singular nouns, and no, plural nouns and singular nouns. So there you go. Patient, yes?
Do you have a key, like, for students if they want to do this?
Yeah, good question. Do I have a key for presenting this at the moment? For the parts of speech and what they mean? At the moment, I don't. That's coming up.
Okay.
That will be added. If you were to look up pen part of speech tags online, you will actually see a full index of that, 38 in all. So you can actually find it online. I have to add that in. Thank you for raising that as an issue. That's coming. As a moment, no, but forthcoming. But some ideas of some possible uses of this in the classroom. For teachers, this can provide an automatic approach for diagramming sentences. There's actually a website that actually kind of sees the use of a computer and the availability of computers and their use in classrooms for teaching, but basically along the lines of mathematics. In fact, a website called computerbasedmath.org. Just as this website aims to use computers as a teaching tool for math, an application like McCawley and its rebranded form, the Parse is Right, can also be a kind of automatic approach for diagramming sentences so that students or teachers can actually use that, and all they have to do is type in whatever the sentence is, push a button, wait, and it actually will draw up the syntax they're in. So it's a tool for being able to automatically diagram those sentences. It allows those opportunities as well to be able to very quickly explore syntax in English in the various forms, in literature, in poetry, and more. In fact, we can actually take this little, well, actually I can't highlight that, so we will come back to that later. For younger students within the classroom, there are some potential uses as well. It actually shows how parts of speech and of those words can fit together within larger structures. Just as we had seen in this demonstration, they can actually see it, especially if they were to come up with a sentence themselves, they can type it in, push a button, and actually see how they fit within larger structures. They can also be able to judge the structures that they utter, or that they are able to write or create. They can actually quickly determine if a sentence is, if what they write is actually a sentence or not. So like, for example, if on a lonely night a traveler, that happens to be the title of a book by the Italian author Italo Calvino, that is not a sentence, even though it's the title of a book. If you actually put that into Macaulay, it will actually be registered as what's called a frag, short for fragment. But you can quickly see, is what I'm writing a sentence? It can actually tell you. It can also tell you if what you're writing in is not just a fragment, but is also perhaps sometimes a part of speech. It can actually assess whether or not something is a noun phrase or a verb phrase, and will actually show that to you, and will still parse, even though it might not necessarily be a sentence. That can be useful as well. You can also explore the staggering variety of possible English sentences. For example, how deep can a sentence go? The furthest depth I've taken this Macaulay app in my tests, 36 levels, using a single sentence, just one sentence from the book Siddhartha by Hermann Hesse. If you ever read that book, the sentences in that are very, very long. I put it through, and it is sometimes kind of cramped to see. The furthest I've taken it is 36 levels, but you can actually see sentences where you actually have this kind of recursive structure. This is the cat that killed the rat that ate the malt that lay in the house that Jack built. And you can actually explore that and be able to push the limits, as it were. For adult students, you can, for example, do comparative analysis of sentences across realms. So comparing the sentence, say, structure of sentences within, say, a newspaper article. Compare that to, say, a post on Facebook, which you would figure is less formal, as opposed to a legal brief, which is very ornate and perhaps very formal. Take examples of that, be able to do that kind of comparative analysis to see how they differ, how they're alike, and so on. You can also discover there are ways, I've actually given presentations, I'll be showing you links to videos in a moment, where you can actually examine the importance of syntax in other realms. For example, within my own realm of software development, the phenomenon of sentiment analysis, that is gauging whether or not what people say carries a positive or a negative connotation, can be quite useful to examine. One example about this that I actually read on the BBC website yesterday. It turns out that sentiment analysis of movie reviews, it turns out is highly correlated with whether or not films that are nominated for the Academy Award might be likely to win. If the reviews themselves have a negative connotation, that means they're more likely to win the Oscar, it so happens. The Revenant, I will actually put myself, they're predicting The Revenant on the basis of this will win the Oscar for Best Picture tomorrow. We'll see what happens. But in any event, that's actually one demonstration of how something like this could be useful. And I had mentioned propositions, idea-bearing units. It turns out that one of the realms where this is useful is in the diagnosis of dementia and neurodegenerative diseases. You can actually look up the research of a project called the Nun Study, where they've actually examined this in some depth. I actually talk about this in the video you'll be seeing a link to in a moment, where it turns out that the number of propositions per 10 words in sentences of nuns who had joined a convent, the Sisters of Notre Dame in Baltimore and Milwaukee, when they actually examined diaries of women who had joined that convent in the 1930s, and then examining their long-term health over the subsequent 60, 70, 80 years, it turns out there was a very strong correlation that they found between the number of propositions per 10 words in sentences in their diaries they wrote when they were in their 20s versus the likelihood they would get dementia and Alzheimer's and other neurodegenerative diseases much later in life. So there's some actual examination about this. I talk about this in some depth in a couple of videos. One in particular. If you go on YouTube, look for The Parse is Right Closure. This is a presentation I gave back in October before a group of software developers that work in the Clojure programming language in which this application was built, called the Chicago Clojure Meetup. Find a video there dated October 14th. I talk about this in some depth and show some examples. There's a similar talk, much shorter, about 6 minutes long, that I actually gave at a major conference that was held in Philadelphia back in November of developers in the Clojure programming language called Clojure Conj, C-O-N-J. It's a pun. There's a command in the software, in the Clojure language called Conj, and this is a pun on that, where they actually named the conference after that command. Look for a lightning talk to this date. I actually give a brief demonstration. If you really want to go into depth, it turns out that the software is online. GitHub is a repository for computer programs, and I've made available the source that actually builds the app that I showed for McCawley and for the Parse is Right. An application programmer interface, an API that basically does the heavy lifting for taking a sentence, parsing it out, and delivering back the data. An HTML front end that actually, the hypertext markup language, the language of web pages. And it turns out that's actually what's used to basically take that data and draw the pretty trees that you see. And a bulk processor, which is able to take that back-end API and able to examine sentence after sentence after sentence after sentence in bulk. The website is available online now, theparsesright.com. I encourage you to use it and to share it. My thanks to a number of people here from my job at Opinion Lab where I work, in particular Mr. Charlie Danoff, who is sitting right here, who brought this conference to my attention, and for which I've signed up, and the conference has graciously accepted my proposal, and a number of folks here who also served as helpful advisees of the development of this. They're all software developers, and helped me in parts where it was sometimes difficult to build the app, but it is now built. So a question has been posed: how does this application handle ambiguous sentences? And it's a great question and a very real issue in the realm of syntax. The short answer is this application picks one picks a version and runs with it with its demonstration. The problem there is that it doesn't really display the kind of ambiguity that you can sometimes see in sentences. It kind of just glosses over that. It picks what it deems to be a likely parsing and then presents that. It does not present anything more than that. That is actually a very serious computational problem as well, because of the number of different parsings that you potentially could see depending on the sentence. So that is...
Can you try it?
We can try. If anyone has a sentence they can try. I mean, actually I can think of buffalo, 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 buffalo. It's 7 buffaloes. I hope I spelled that right. Switch to, press parse. And this is going to come back as, it's a little hard to see, let me spin it up. So this came back as an inverted sentence where you actually have the verb phrase first and then the noun phrase afterwards. It turns out that there's a sentence that actually comprises 7 strings of the word buffalo, referring to a verb meaning to basically bowl over, the city buffalo, there's an adjective of it, and you actually can draw a parsing of it. Unfortunately, the app isn't smart enough to know all those parsings and how they can fit together, and so this is what it actually delivers back. There was another version of this where it actually came back with actually a single noun and then a single verb phrase and a bunch of nouns at the very end. So yeah, it's not perfect. In the overwhelming majority of cases, it will do, but yeah, so be forewarned. We had a question back there.
I had a question about what you do. Visiting relatives can be annoying.
Sure. Visiting relatives can be annoying. No, there's an ambiguity there. You'll sometimes see this in newspapers, so let's parse that out and see what we get. So that comes as a noun phrase. So it's referring to relatives as a noun, not the visitation of them. There's an MD short form modal, words like would, should, can. Be, there's your linking verb. An adjectival phrase with an adjective, that's what JJ means, annoying. Visiting relatives. Visiting being an adjective, not as a verb. So that's how it handles it in this case.
My question though,
Yeah.
sorry.
Yeah.
Do you run into any issues at all of the parsing being inaccurate in your estimation?
Do I run into any issues? And the short answer is yes. And I will actually critique the application myself and say, no, it could have done it a little better this way. By and large, though, I think it's pretty on the mark, probably accurate, and this would be something to be able to research. I've not actually seen how well does it actually handle like large-scale sentences in comparison with how professional syntacticians, for example, would be able to do. My feeling is probably pretty well. I'd probably ballpark it at maybe 80 to 90%. That remains to be seen, though. We had a question back there?
A tool that students could use to show their mistakes. If they enter a sentence that is not grammatical, how will it handle it? Will it give them feedback that they're using it?
Yeah. So the question is, if it's something that would not parse as a sentence, will it give feedback? And the answer is yes. I'll give an example. If on a lonely night a traveler. That is not a sentence. It is a title of a book, though. If you parse that out, this is what I was referring to. This is a frag, short for fragment. Because prepositional phrase plus noun phrase is not a sentence.
If they forgot a helping verb or something like that, but it's say fragment too.
It might. In my experience, it actually is pretty forgiving of that sometimes. So if you have an example, and the website is online now, you're welcome to. The way it works is you've got a reset button that clears it out. You can type in whatever you want in here. It actually appears you can't see this in the screen and the presentation here, but there actually is a gray box on the screen when you actually visit it on the web. Click reset. If you can't come up with a sentence yourself, there's a random button that provides you with a very helpful sentence example. To the red country and part of the great country of Oklahoma, the last rains came gently and they did not cut the scarred earth. So you can parse this sentence from the Grapes of Wrath, and it'll actually draw it out for you in case you need a sentence. I've stored about 40 sentences of various fame and vintage or the stuff that my wife and son made up, and then put them in the app. And they look like this, kind of colorful. Other questions? Yes?
So what's trying to get the key to all of the
what's the website? They are, so here, whoops, let's shoot. So the website is GitHub, github.com.
Okay, so that'll have all the.
That'll have the software. If you want the application, that's the parsesright.com.
Okay, so
Mhm.
if I don't know what JJ is.
Oh, that. You would
Yeah.
Google the words pen, P-E-N-N, with 2 N's, tags, parts of speech. Those are pen tags for the University of Pennsylvania, which devised the system. And you'll find them online.
So pen tags, is that one word?
That's 2 words. P-E-N-N, space tags. Yeah, a reference to Penn, short for the University of Pennsylvania, which developed the system. Yes, other things? No? Yes, Charlie.
If people have like sentences that don't work, or can they get in touch with you?
That is a great question. If you, right here in my opening slide, I'll actually bring it. Also listed in the ITBE catalog. So if you look at the presenters, all you have to do is just spell my last name, Szczepańczyk.
Just like it sounds.
Yeah, exactly. Actually, that's true. If you follow the pronunciation patterns of Polish, it is pronounced exactly as it's spelled. My email address, my website, I'm also on the Twitter. I welcome your feedback and any concerns you have. I have to admit, I have not actually put a link of my own email on the app. I have to do that too. So I have to put a key regarding the pen tags and also my own email address. But rest assured, probably in a day or so, they will be up.
So besides fragments,
Mhm.
would it show like run-on?
Does it show run-on sentences? No.
That's the only
Right.
incorrect.
Yeah, the good question, because there's no syntactic analog I can think of that actually denotes a run-on. And it's basically just showing you the structure, how they fit together. Again, if you have an example of a run-on that would be suitable, I invite you to do that, to use that. Feel free to email me, or if anyone can come up with a sentence right now for that. We've got the app open now. This offer is not for a limited time. The website will be up after the conference.
I would just make a sentence that has no conjunction, you know. I like to eat, he likes to play.
I like to eat, he likes to play. You mean like this? Do we want to add in a period or a semicolon? Or?
Put a period at the end.
No.
So just like this. I like to eat, he likes to play. Okay. All right, so then I'm going to parse that out and see what we get back. Aha! It actually is, it does recognize it as 2 sentences. This is an intervening sentence inside a noun phrase. This is referred to as an S-bar, a sentence within a sentence. But you're right, it's kind of convoluted. It doesn't recognize it as 2 sentences. This app actually handles 1 sentence at a time under ideal circumstances. I have written a portion of a code that is not yet available, but actually can handle, if you were to type in, let's say, 2 or 3 sentences, it would actually parse them as 2 or 3 sentences, not as one big mess like this. So that's coming too. Other questions? I hope you found this enjoyable and useful. I invite you to use it, and I look forward to any further questions you may have. You may reach me later. Okay, then quick time. Yes, hi.
Oh, I'm presenting at 11:15.
Oh, excellent.